Hello everybody, and greetings from the Delta College Planetarium. My name is Brian, and I'm here to talk about comets. Right now, there is a comet visible to the naked eye in the night sky from Bay City, Michigan. We already have a video that describes basic observing techniques and points out the location of Comet NEOWISE. This video is going to explore comets more generally. Historically, comets were viewed as blemishes on the otherwise perfect stars, and so they were frequently interpreted as omens of doom. Their appearance foretold of plague or discord, the removal of a king, or the failure of the year's harvest. Setting aside the specific details of our particular moment in history, these are thankfully rare in our lives today. And we know that comets are not messengers of ill tidings. Comets are chunks of rocky and icy material from the outer solar system. Inside the orbit of Jupiter, it's difficult for ice to exist. The light from the sun heats up ices enough that they sublimate. Sublimation is the transition of a solid form of matter to a gaseous one. Dry ice, which is made of carbon dioxide emitting clouds of gas, is the classic example of a sublimation process. So, where ice exists in the inner solar system, there must be specific local conditions encouraging its existence, such as the atmospheric and hydrologic circumstances on Earth and Mars, or ice collecting inside deep craters at the poles of the Moon, which are sheltered from sunlight. But in the outer solar system, ice is stable in sunlight, and so we see many of the moons and objects from the outer solar system being primarily made of ice. Most of the comets in the solar system live in an area called the Oort cloud. The Oort cloud is a spherical distribution of icy bodies around the solar system. The inner edge of this cloud lies about 1,000 times further from the sun than the Earth does. And the cloud may extend to almost 100,000 times the distance between the Sun and Earth. While we believe that there are a large number of objects in this cloud, they are on average about the distance from the Sun to the planet Saturn away from each other. The Oort cloud is the very outer edge of the solar system. Because the force of the Sun's gravity is very weak out here, it doesn't take much to nudge one of these objects out of its orbit. And that can cause it to fall in towards the Sun and planets. This object is called a comet nucleus. It's mainly made out of icy material mixed with some rocky material. The ice portion doesn't have to be water ice like we're used to on Earth. While that is a large portion of the comet also includes exotic ices like ammonia ice and nitrogen ice. Once the comet nucleus crosses the orbit of Jupiter, the sunlight heats the surface enough to begin the sublimation process. These ices turn into gas in the sunlight and stream away from the surface. These gases can carry along some of that rocky material with them. The entire nucleus will become wrapped in this cloud of gas and dust, many times its size. This is the comet's coma. When we see comets in the sky, we're never able to see the nucleus of the comet directly. The dust and gases of the coma will start to lag behind the comet nucleus, which is still accelerating towards the sun. Each of these tiny particles is still in orbit though, so that cloud gets smeared out, trailing behind the comet, and forms the comet's tail. This dust tail mostly follows the orbit of the comet. Some of those particles are electrically charged, and these ions behave differently. They interact strongly with the charged particles streaming away from the sun, what we call the solar wind. These particles will be blown directly away from the sun and glow blue. This means that the white dust tail of a comet and the blue ion tail of the comet don't have to point in the same direction. In fact, sometimes they can point in wildly different directions. Comet orbits are usually highly elliptical, and they may take hundreds or even thousands of years to come back to the inner solar system again. Presently, Comet NEOWISE is visible in the northern sky. This comet is newly discovered and has a period of about 6,800 years. It's impossible to know if NEOWISE has ever visited the inner solar system before because written records don't exist that far back, and it predates the invention of optics. So NEOWISE is illustrative of the problem we face. Comets can fall out of the Oort cloud and into the inner solar system without any previous knowledge about them. Because the Oort cloud is spherical, they can come from any direction. It's entirely possible that a comet could be on a collision course with Earth, on its first trip into the inner solar system. This is why it is deeply important that we continue these large-scale telescope survey missions to identify novel small solar system bodies. The sooner we can detect a dangerous comet, the better chance we have to deal with the consequences. I don't want to scare you, the threat is very, very small that a comet will impact the Earth anytime soon, but it is real. While we're out doing that important job, we can still appreciate the splendor of a comet in the evening sky. Comet NEOWISE is visible in binoculars in the northern sky starting about an hour after sunset, and visible to the eye about 90 minutes after sunset. The comet's tail fills the field of view of my 15x75 binoculars. The comet will continue to climb in the evening sky, and on July 22nd, it will reach its closest approach to Earth, about 100 million kilometers away, or 2/3 the distance to the Sun. NEOWISE will continue to dim as it recedes from the inner solar system, but we hope that it will remain visible for a couple of weeks. So if it's clear where you are, go out and look for Comet NEOWISE in the evening sky. Visible comets are rare, so take every chance you can to appreciate this celestial visitor. This is Brian from the Delta College Planetarium, wishing you clear skies.